Today we are going to do binomial theorem chapter. So in this, actually every pattern will be like the binomial theories in used to actually it all the patterns, all the questions will be in the form of a plus b whole power of n, and here this we are going to extend this form. Okay, so it is like expand the brackets of this form where n is a whole number. Okay, so 0 onwards it's going to start. So why this chapter is introduced, like why why it has extended this things is like, suppose you know a plus b power of 0 is what here 1. So if I take a plus b power of 1, then your answer is a plus b, right? Then if I take a plus b whole square, then what is your answer? A square plus 2ab plus b square, right? Then a plus b whole cube if I take it, then a cube plus 3a square b plus 3ab square plus b cube. So like this we know certain numbers, right? So on, if I want to find a particular term, like if I increase a plus b whole power of 2025 something, if I want to find, then how we are going to find the value of that? So like that only this binomial has introduced, and they I think you know Pascal's triangle has introduced based on this only. So based on this Pascal triangular only, we are going to have this final part. So just we'll check with the Pascal's triangle. So first of all, when it is 0, yours is 1, right? Then next is, if it is the power is 1, so what is the powers of here is 1, right? So then 1 and 1, I'll write little here, 1 and 1. When power is 2, when power is 1, the 1 and 1 we got it as a power over here. Then if power is 2, what we got it here? First one is what here? So here is not for this Pascal triangle is not, sorry, the Pascal triangle is not for the powers. These are the terms, like constant terms. So here it is, a constant term is only the 1, it's not 0, it's 1. Then the coefficient of A is what? 1. Coefficient of B is what? 1. Now here also coefficients you check it. There is nothing as that is the 1. Okay. Then here coefficient is 2, and then here coefficient is 1. Right, like that only. If I check it here, 1, then here it is 3, and then 3, and then 1. So it's going in a pattern, right? It's going in a pattern. The next also, if I go for the x power 4, then here also, see, the pattern is based on the adding this both and writing. So 1 plus 1 is 2, and here also 3. How we got 3? 2 plus 1 plus 2 is 3. We got it a 3 over here. Here also 2 plus 1 is 3, we got it. The same way, if I want to write an x power of 4, if I write it, then what I am going to get? First one and the last one is a 1. Then the middle, here this both in the middle is what? 1 plus 3 is what? Here 4. Then 3 plus 3 is what here? 6. Then next is 3 plus 2 is how much? 3 plus 1 is 4. So this is the way we are going to get it. Okay, this is the pattern. So like this only we have it follows a pattern of it. So by this process only we are able to find end of, like, whatever the power you have, that power we can find it. So till now I think you understood. So here is the representation of these terms. We are going to see how to represent these numbers. Okay, so we'll see this one. Suppose here it is a power as 1. So can I write it this one as 1c0 and 1c1, and it is power is 2. So I'm going to write it as 2c0, and this one is 2c1 and 2c2. So when it is starting 0 and the 2, that both becomes a ones. Okay, so in binomial also the coefficients will be from the first, and the binomial coefficients for the first and the last will be the same. The next is, this one is the power is 3, so I can write as 3c0, and this is 3c1, 3c2, and this is 3c3. Then here it is 4, this is a 4, so 4c0, this is 4c1, 1 it is, and 4c2, 4c3, 4c4 is yours, right? This is yours. And then this is a pattern, like that it's going to be. So I think if you know nth term, a power of n is also, we can write as a similar way, a plus b power of n. Suppose this is the n, if I write it n as, then how can I write the pattern of the coefficients here? So first of all, nc0, then it is n plus nc1 plus nc2, so on. Finally ncn is your binomial coefficients. This coefficients is we got it like this. I think the coefficients you understood. And the next thing is how many terms. If anyone asks you how many terms it is, so terms is, suppose if it is 0, then your terms are 1. So if the power is 1, then your terms are 2. If the power is 2, then your terms are 3. If the power is 3, then your terms are 4, right? 1, 2, 3, 4. So like that only the terms, if anyone asks, then the number of the terms in the binomial theory is n plus 1. That's the terms, number of the terms. Next we'll go to a pattern like, so a plus b whole power of n. So here also you are able to see if it is the square, right? So a and b. So if we'll see in this, here it is a cube, first one is a cube, and then a square, a power of 1 and a power of 0. So the first term powers are from it's in decreasing way, right? And then the second term, it is in increasing. Here is b power of 0, b power of 1, b power of 2, and b power of 3. So here is also a pattern. Now we will follow the same thing in this also. So first one is the first a power of n, then b is not there in the first term, then here nc1, a power of n minus 1 is reduced, then b power of 1, right? The next one is here in the third term is what here, nc2, so here is a power of n minus 2, then b power is 2, right? Then if I go with the third term, nc3, a power of n minus 3 and b power of 3, so on. Here if I write ncn, a power of a is gone, n minus n is 0, so a term will not be there, and then b term, b is b power of n. This is what the process of like standard form of a plus b whole power of n, opening the brackets. Then if I have a negative in the between, suppose a minus b whole power of n is equals to, so you can keep minus, suppose this minus I can write it as a minus b. So if that minus, if you substitute it, say wherever you'll get, wherever places you will be getting b power of 1 as a negative, b power of 2 becomes a positive again, then b power of 3 is a negative. So alternatively you are getting a negative. So I can write it as nc naught, a power of n is the first term, second term is a negative, nc1, a power of n minus 1 and b power of 1, plus nc2, a power of n minus 2 and b power of 2. This is because it's a square, it is a positive. Then next minus nc3, a power of n minus 3 and b power of 3. Because it's an odd term, you are getting a negative over here. So on ncn, b power of n. So this is the pattern or standard form of a binomial theorem. Okay. So suppose if they ask any particular term. So by observing this, what you can write it here, what you can write it in this. So particular term, we'll write a particular term of it. So I'll just write it. Yeah. So see T sigma, like, okay, or first of all, T R plus 1 term, okay, by observing some particular term I'm writing, okay na, T R plus 1 term, yeah, T R plus 1 term. Then what is here? Suppose a particular R term is here. So suppose if you take a 2, means what? 1 plus 1, right? So I'll take those things. Now, I was not clear to you. This is the first term. So first term, what is here? 0. This is second term. Here it is 1. Third term, it is 3. So whenever the term minus 1 it is, right? So here also particular term means R is what here? Yours NCR, right? 1 as like before the R term it is. So suppose R plus 1, then here your value is NCR, right? Then here what you're going to get, a power of NCR, then a power of n minus 1. Suppose whatever the R is here, n minus R. So here is also n minus R, and b power of R. This is the nth term. Any particular term, whatever the term if you are taking, you can write it as like this. Suppose here, because like we are taking all the terms, sum of all. So sum of all is what? Sigma R is equals to 0 to n terms, right? So n terms you will write it here. So here is also sigma R is equals to 0 to n terms. So the format, if you write like this, it shows that all of them, all the terms over here. Okay. Then we have done this part, and we'll check with the if a plus b whole power of 4 and a plus b whole power of 5 and 6. Shall we check these things once? We'll write it and we'll check it. Okay. I think it is becoming easy for you all to write it, and let me write those all things. We'll do these things. I think by the explanation you can easily do this, but just once we'll try with this. So here is 4c0 x power of 0, right? Sorry, x power of what it is here? 4 minus 0 is 4, and y power of 0. So y power of 0, shall I write it or shall I remove it off? I'm just removing it. Y power of 0 is 1, so I'm just leaving it off. Then plus 4c1 x power of 3 y power of 1 plus 4c2 x power of 2 y power of 2 plus 4c3 x power of 3 x power of, is it 3 or 1? 1 it is, yes. Then y power of 3, the next last 4c4 is the last one, right? It's an increasing, yeah. Then x power of 0. So x power of 0 is what? 1. So I need to try it here. Then y power of 4 is your expansion. Then the next one, if it is minus, then what you are going to write? 4c0 x power of 4 minus here, because why we are taking it as a negative, y power of 1 is a negative. So we'll write it here. 4c1 x cube y power of 1. This is a square, so positive. 4c2 x square y square. So you don't need to remember all the time whether it is a positive or negative. Just alternatively you can keep it a minus. This is a plus, minus, like this. So here after the plus, minus 4c3 x power of 1 y power of 3. Then plus 4c4 y power of 4. Then next we'll go for the x plus y whole power of 5. So here is 5c0 x power of 5 plus 5c1 x power of 4 y power of 1 plus 5c2 x power of 3 y power of 2, 5c3 x power of 2 and y power of 3 plus 5c4 x power of 1 y power of 4 plus 5c5 x is gone, then y power of 5. You all understood? Next is minus. So 5c0 x power of 5 minus 5c1 x power of 4 y power of 1 plus 5c2 x power of 3 y power of 2. This is minus. Here is a plus. This is minus 5c3 x power of 2 y power of 3 plus 5c4 x power of 1 y power of 4 minus 5c5 y power of 5. Then we'll go for the, suppose if it is 3 terms, then you can take this one as a, and this is the first term and the second term. Okay, you can write it, consider like that, but in the writing part you can keep a plus 1 plus x. You can take even this both also the one part and this is also a one part, but as it is one, we can take this both as first one term. So the same way, 3c0 first is what, 1 plus x power of 3, then plus 3c1 1 plus x power of 2 and x square, right? Then plus 3c2 1 plus x power of 1 and y power of y. So y is what here? Y is x square, right? X square of 2. Then plus 3c3. Then here is 1 plus x will not come. So x square of 3. Like this way. Okay. We have done this then. So I think all of you got a clarity about what we are doing. So overall, I'll just give a points like what we come across till now. I'll just write and I'll show you. So I have written here some like points to remember. The expansion of a plus b whole power of n has n plus 1 terms. We have seen first only. So the expansion will be how many terms? If it is 3, the n is 3, then the expansion is n plus 1. Means 3 plus 1 is 4. This is 1, 2, 3, 4. 4 terms. Like that only everything comes. In each term, sum of indices of a and b is. So if you add it all, then a from 0 to n and b is alternative. So this is what we have seen already. And then NCR. Suppose if you're as in the terms NCR, suppose see this one and this one is equal. So a particular term NCR is equals to the NCR minus n minus 1. This both the terms values will be equal. Here also the first term and the last term values will be equal to 1, and the second one and the previous to the from the last to the second is also will be equal. So that's what the coefficients of terms are equal distance from the beginning and the end. So beginning first and the last and the next first and the last, like this it comes, all will be like equal distance from the first to the last. Okay. So this is a basic part, we have learned it. Then we'll go to the sub problems and we'll check it here.